In this presentation, we're going to cover how to do probability calculations for a random variable. So for our first example, let's assume we have a random variable x, and this random variable represents the number of on-time flights at Phoenix Sky Harbor Airport. Now we know that none of the flights could be on time, and all of the flights could be on time, and the maximum number of flights at Sky Harbor Airport are 30 each day. So let's think about two things. The first thing is it discrete or continuous? Well, it's discrete because we are counting the number of times. So it's not something that falls on a real or a numerical value. Why is it a random variable? It's a random variable because we cannot predict with 100% accuracy the number of flights that will be on time. So let's do some calculations. So we know again that x goes from 0 to 30. And let's just break this up so we can see it a little easier. We've been given some probabilities. We know that the probability of all flights, or flights more than 20 flights, or 20 or equal to 20 flights, is equal to 0.03. And that represents this space. We also know that x equal to 0 is equal to 0.12, which is represented here. And we know that x equal to 1 is equal to 0.04, which is represented here. And lastly, we know that the probability of the number of on-time flights ranging from 1 to 4 flights is equal to 0.8. And that's represented here. So up to 4. And here. Underline that for you. So, what if we're asked to compute the probability? Let me choose a better color. Let's see if what if we're asked to compute the probability that the number of flights leaving on time falls between a range of 0 to 4 flights. In this case, what we need to do is we need to add the probabilities that fall within this range. So the range between 1 to 4 is covered in this probability, and the range of 0 is covered in this probability. So we add the probability of x equals to 0 plus the probability for the range between 1 to 4, which is 0.12 plus 0.8, which is equal to 0.92, or 92%. Let's do another example. Or let's do an example, another probability example. So let's say we want to find the probability that x is less than 20. Now we know that the probability of x falling on this entire line is going to be 1. And we know that the probability of anything greater than 20 is captured in this probability. So for us to get the whole thing, minus just the piece that we really want, which is this part, what we need to do is we need to subtract 1, so the possibility that it could fall on any part, minus the probability of anything above 20, which is equal to 0.97 or 97%. So now let's do an example for a continuous random variable. And let's say that this random variable is the time over that, if a flight is late, how late it is. So it's the time past when it was due. So that means that x could, or well actually in this case we're going to call it y. Y could range anywhere from 0, so it's not overdue, to some infinitesimal amount of time that we can't actually predict. But we do know that we can measure time infinitesimally. And let's say we are given probabilities. In this case, we're given a probability that y greater than 10 minutes is equal to 0.12. And let's say 10 minutes is here. So y is less than 10, or excuse me, greater than 10. It's represented here. And then the other probability we're given is y, or excuse me, 1 from the range of 1 to 10. So if 1 is here, that probability is represented here, and that value is 0.8. So what if we're asked to compute the probability that y is less than or equal to 1? So that means in this case we are trying to figure this out. So how do we solve that? Again, we know that the possibility that the time could fall along this line at any point is 1. So we know that it's going to be late at some point in time, if it's not 0. And we know what this is, what the range from 1 to 10 is, and we know the range from 10 to infinity. So in this case, we need to subtract 1, or from 1 we need to subtract the probability that it falls, that y falls between 1 and 10, minus the probability that y is greater than 10. So in this case, 1 minus 0.8 minus 0.12, which is, hold on, let me grab my calculator. Be patient. Is 0.08. So this, I hope you've seen from this presentation that we can use probabilities that we've been given to calculate other probabilities for a given scenario. So this allows us to use the probabilities that we have to, see how other situations are also probable using this data. So I hope that you understand how to calculate probabilities both for discrete and continuous random variables. Thanks.